Moving on to part 3 of mechanics, and we're looking at free fall and projectile motion. Objects in free fall, well, only gravity will be acting and nothing else. The object will be undergoing an acceleration of g, where g is the acceleration due to gravity, which acts downwards towards the Earth, and its magnitude will be 9.81 meters per second squared. Now, if we presume that there is no air resistance, and that's a big assumption, then all objects, regardless of their mass, will accelerate at the same rate when they are in free fall. Air resistance does complicate things. If we look at the example in the diagram opposite, the force acting down on the man will be caused by gravity, but air resistance will be a force acting in the opposite direction. So you'll get a resultant force on the man which will slow him down, which is just as well. So in free fall exam questions you will generally be told to assume that there is no air resistance, and all you need to do is to take your equations of motion, and where you see the letter A for acceleration, you just substitute the value of g, the acceleration due to gravity, which is 9.81. Moving on to projectile motion, which is quite useful if you want to calculate all sorts of different things. And the first example we're going to look at is a girl who throws a ball horizontally from the top of the cliff. Now the ball has a horizontal velocity of 10 meters per second, and it takes 5 seconds to hit the ground. And in this exam question you are asked to find the height of the vertical drop of the ball and also the horizontal distance travelled by the ball. Now a hint with all of these projectile motion questions is always to do the vertical bit of the motion first and then do the horizontal bit. So if we look at the equation which is circled in red, that gives us an equation for displacement, so we can use that for the vertical bit of the motion. So we need to find out what u is, what the initial velocity is. Now remember, this is velocity in the vertical direction, and if the girl is throwing the ball horizontally, there won't be any velocity initially in the vertical direction, so u is 0. And a, as we've discussed, is acceleration due to gravity, so that's going to be 9.81. And you were told that the time taken for the ball to reach the ground was 5 seconds. So you can substitute all those figures into that equation and find that the ball will fall 122.6 meters to the Earth. The second part of the equation involves finding out the horizontal distance travelled by the ball. Well, the horizontal motion is unaffected by gravity, so the speed will remain constant, and the speed was 10 meters per second in the horizontal direction. So if we multiply 10 meters per second by 5, which is the time it takes to reach the ground, then we've got the horizontal distance travelled is 50 meters. If we're looking at projectile motion that starts at an angle, you use exactly the same equations, but obviously you have to work out from the initial velocity how much of that velocity is acting in the vertical direction and how much is acting in the horizontal direction. So you have to break down that initial velocity into its vertical and horizontal components, and you do that using trigonometry. Now if you've got a ball that is travelling along a trajectory, remember that when the ball reaches the top of that trajectory, then its vertical velocity will equal 0. And remember that in a symmetrical trajectory, the time taken to reach the maximum height will be exactly the same as the time taken for the object to come down again. And again, the horizontal component will be unaffected by gravity, so the horizontal component of the initial velocity will be u cos y, and all you do to find the distance is multiply the velocity by the time, so it's u cos y multiplied by time. And that's the end of part 3.
Created using Powtoon.